This is a Friday Shoes production. This is lesson 4-3 on page 198 in our books, and the target is I can find rates of change. What's a rate of change? A rate of change is a rate that describes how one quantity changes in relation to another. Let's take a look at the example. We're going to do a positive rate of change here, and we're looking at this wonderful chart that says that Alicia's email contact list had 10 entries in 2004 and 38 entries in 2006. Let's read the question. It says Alicia had 62 entries in her email contact list at the end of 2007, which is not on the table here. Use the information, though, to find the rate of change in the number of entries in her email contact list between 2004 and 2007. All right. Well, first off, let's get the details that we need. We got the entries, which is 10 in 2004 and 62 in 2007. What we need to do is find the change or difference in the number of entries from 62 to 10 and the change of difference from 2007 to 2004. So let's write a rate that compares the change in each quantity. Notice we're going to find the change in the entries, which is 62 minus 10, and then also the change from 2007 to 2004. We're creating basically a fraction with the top being the entries and the bottom being the years. So here we are. We have 52 entries over 3 years. Of course, it says subtract to find the change in the number of entries in years, and we did that. When we get that, we have 17 entries over 1 year, which is 17 entries per year. It says that's the unit rate, and you have 1 on the bottom. So since this rate is positive, meaning it doesn't have a negative change, it's a positive change, she has more, Alicia's email contact list increased or grew at an average rate of about 17 entries per year between 2004 and 2007. Go ahead and you give it a shot here. It says the table shows Raymond's height at age 8 and 11. Find the rate of change in his height between these ages. All right, well, let's take a look. We're going to go from 51 to 58 and then 8 to 11. Not a problem. So we'll find the change, which is 58 minus 51. And we'll do the age, which is 11 minus 8. So it looks like we have 7 on top and 3 on bottom. When we actually calculate this out, we can say that that's 2 1/3. We're talking about inches. So on average, he's grown 2 1/3 inches every year. Here's something else we can do. It says a graph of the data in example 1, which we did, which was the email contact list, is shown here at the right. The data points are connected by a broken line segment to show that the rate of change is going up. It says a positive rate of change is shown by a segment slanting upward from left to right. So you can see we're going up. But notice it's dashed. That means that the information, if you read down here on the tip, says a broken line means that there are no data points in between. We just have a data point here and we have a data point here. Solid line would mean that we have data points all through. And again, it's going upward, so therefore we have a positive rate of change. And if it was going downward, we call it a negative rate of change. Something I want you to put in your notes is just that, our rates of change. Notice the first one, this is our positive rate of change. We call that an increase, and that shows on a graph going up from left to right. And we go from left to right. If it's going up, we call that a positive rate of change. If it's going down, then we call that a negative rate of change or a decrease. And if it just goes across horizontally with no up or down change, we call that a 0 rate of change, and that just means there is no change. You don't have to copy the whole graph, just simple things. Pointing a line going up would be positive, down, negative, and of course across would be 0. Example 2 here. We're talking about a negative rate of change. We have personal computers here, the average cost, and then the year. Notice it kind of looks like it's going down there. What is the question? The graph shows the average cost of personal computers from the years 1997 to 2002. Find the rate of change in cost between 1998 and 2000. Describe how this rate is shown on the graph. Okay. We'll take a look. It says make a table of the data using the coordinates of the points listed on the graph. Well, 1998, we've got $1,300. 2000, we've got $1,000. All right. It says use the data to write a rate comparing the change in cost to the change in years. Cost comes first, that'll be on top, and the years will be on bottom. So we take the 1,000 and we subtract the 1,300. We also take the 2,000 and subtract the 1998. When you do that, you'll see we have a negative 300 on top and we have a 2 on the bottom. What does that mean? We're going to express our answer, of course, as a unit rate, which is just reducing that or dividing those two. We have negative 150. In this case, it's going to be dollars over 1 year. So we would say that the rate of change was negative $150 per year. The rate is negative because the average cost of a personal computer decreased between 1998 and 2000. This is shown on the graph by a line segment slanting downwards, as we just described before. I'm going from left to right, downwards. How about you try these, B and C? Same graph. It says, in the graph, find the rate of change between 2000 to 2002. So we're going from 2000 to 2002. In 2000, we had $1,000 cost, I believe. Yeah. And then in 2002, we have a $855 cost. So here's what we're going to do. We're going to take $855 and we're going to subtract 1,000. And then we're going to take 2002 and we're going to subtract 2,000. When we do that, on the top, you can see we're going to get negative 145 all over 2. And negative 145 divided by 2 is going to be negative 72.5. What is that saying? That's saying that the average cost, if I can use the space over here, the average cost per year went down $72.50 between the years 2000 and 2002. So I'd write that, and I'd say per year. All right, how about describe how this rate of change is shown on the graph? Well, it's shown on the graph by, you can see a slight negative change from here to here. It's going downward. So I would just say downward slant. All right, last example. It says compare rates of change. We're talking about webmasters, people who work on the web and collect data for us. How does a webmaster use math? It says webmasters are responsible for designing and creating websites. They often create their own programs using a specific computer language. This requires strong logical reasoning skills. You can see our graph over here. It says U.S. Internet users. Talking here now. So there's numbers of millions of people using the computer. And we're talking about the years between 2000 and 2006. They go up in increments of 2, it looks like there, 2 years. It says the graph shows the number of internet users in the United States. Compare the rate of change between 2002 and 2003 to the rate of change between 2003 and 2004. So we're going to check out 2002 to 2003. And then we're going to take 2003. So we're going to do this one. And then we're also going to see this one. 2003 to 2004. It says the segment from 2003 to 2004 appears steeper. You can see the reds appear steeper than the segment from 2002 to 2003. So it appears the rate of change between 2003 and 2004, the red one, was greater than the rate of change between 2002 and 2003, which would be the blue one. Well, we need to actually prove that. So let's find and compare the rates of change. Take a look at what they've done for us here. It says from 2002 to 2003, they're doing the calculations for us. They're taking the 160 and they're subtracting the 158. Excuse me, the 161 and subtracting the 158. Obviously, they're taking 2003, subtracting 2002. That comes out to be 3. And in this case, we're talking millions. So it'd be 3 million per year. Now, from 2003 to 2004, I'm taking 190, subtracting the 161, 2004, subtract the 2003, and we're getting 29. Well, there you go. 29 million per year versus 3 million per year. What would we say? Well, since 29 is greater than 3, the rate of change between 2003 and 2004 is greater than the rate of change between 2002 and 2003. And we have a little check there. We've just checked it. All right. Last example here. It says use the table to make a graph of the data during which 2-year period was the rate of change in oil production the greatest. Explain your reasoning. Funny because we're just talking about oil in class. They've taken these forms, and actually I've created this for you here. So we'd have some graph paper. We would have a little break in the graph so that we didn't have to write it all the way down to 0. And we could just show the tops here. And this goes from 96 to 2006, as you can see in the table, and then also on the graph. Now again, it says, during which 2-year period was the rate of change in oil production the greatest? Doesn't matter if they're just asking for the change in oil production, not if it's positive or negative, just which one is the greatest production change in the oil production. All right. How do we explain this? We're going to take a look. It says from 1998 to 2000. 1998 to 2000, right here. You can tell the rate of change shown on the graph is greater than the other 2-year periods. So any 2 other year periods that you see, this one's steeper. So we might say it's steeper than the others. Now it's going down, so the production change was a negative, but it still is just the change that we're worried about. And that's what this little tip is right here. It says when comparing negative rates of change, just compare the absolute value of the numbers. Basically, subtract the big one from the small one and use that number. And this would come up with the greatest change. Don't forget, you can always watch this video again or read the examples in the book. They're just the ones I just did. You can also watch the personal tutor videos in the resource of the online textbook. And as always, this is a Friday Shoes production.